So in this video, I'm going to walk through one example of using Minitab Express to construct a sampling distribution to conduct a hypothesis test. The data that I'm using are from the textbook, Chapter 5, Section 1, Question 5.7. This particular question just asks you to find the standardized Z-test statistic, so we'll do that. And we're going to take it a step further. I'm going to show you how to use that to find a p-value in Minitab Express. After we do that, I'll also show you how you could find the same p-value without doing the standardized Z-test statistic step. So here we have a right-tailed test. The null hypothesis is that mu equals 80. The alternative is mu is greater than 80. So it's a one sample mean test. We have a sample size of 20. That's information that we actually don't even need. A sample mean of 82.4. We will need that. A sample standard deviation of 3.5, which we actually don't need because we're given the standard error of 0.8. So in this chapter, you're always given the standard error. Next week, we'll see how, if we were not given the standard error, how we could compute that using the standard deviation and the sample size. But for right now, all we really need are the alternative hypothesis, the sample mean, and the standard error. So the first method that we're going to use is the standardized Z-test method. So the first step here is to compute the Z-test statistic. I'll hop on over to the online notes so I can show you that formula. So here we have our general formula for a test statistic. The test statistic, in this case Z, is going to be equal to the sample statistic minus the null parameter divided by the standard error. So our sample statistic is the sample mean, x bar equals 82.4, minus the null parameter. This is the number in your null hypothesis, in this case 80. And then the standard error we were given to be 0.8. So 82.4 minus 80 is 2.4 divided by 0.8 gives us a Z-test statistic of 3. That's all this particular question was looking for, but we're going to go a step further and we're going to find the p-value for that test statistic. So in Minitab Express, I am going to construct a probability distribution plot to display a probability. We have a Z-test statistic, so we've already standardized this. So the Z distribution has a mean of 0, a standard deviation of 1. We have a test statistic, which is an x value. We do have a right-tailed test. And we have a test statistic of 3. So our p-value is going to be the area to the right of 3. In this case, our p-value is 0.0013499. Now I'm going to show you how you can do this in Minitab Express without doing that Z transformation. So we can again construct a probability distribution plot to display a probability, but this time we're going to use information about the sampling distribution that we were given. So we know that it has a mean of 80 because that's the number in our null hypothesis, and the standard deviation is the standard error, so 0.8. Our specified x value is now the observed sample statistic, 82.4. So in other words, we have a sampling distribution with a mean of 80 and a standard deviation of 0.8. We're doing a right-tailed test, and we want to find the area that is greater than 82.4. This should give us the same p-value, or approximately the same p-value, and it does, 0.0013499. So the step that we took in the middle of computing the Z-test statistic is optional. You'll see that most softwares will do that for you. Next week, we'll do Z-tests and T-tests and Minitab Express, and it will compute that standardized Z-test statistic or T-test statistic for you, and it'll compute the p-value for you as well. This week, we're just doing it all manually so that you can see where all those different values are actually coming from.